Okay, hi guys. So in this lecture, we'll be talking about percentage yield. Okay, so let's get started. So percentage yield is obviously you can define it as the actual yield of the product over theoretical yield of the product into 100. Okay. Over theoretical yield of the product multiplied with 100. Okay, so which can also be written as actual moles of product formed over moles of product formed as per stoichiometry into 100. Okay, actual moles of product formed, moles or mass you can also say, of product formed over moles mass of product that should have been formed at stoichiometry into 100. Okay, so let's say we have 2 moles of A plus B gives 3 moles of C. Okay, and moles of this compound are 8, 6 and 12. Okay, so obviously this was the limiting reagent. Why? Because the molar ratio, or rather the moles to stoichiometric coefficient ratio of A was lesser, so hence this was the limiting agent or limiting reagent. Okay, and this will derive the moles of product or C. So if the actual moles of C formed is 9, okay, due to some impurity or something else, okay, some reaction happened with the atmosphere and some C was lost due to some of the accident. Okay, there are many real life scenarios in which industrial accidents can happen. Okay, so if actual moles obtained of C obtained were only 9, okay, so percentage yield would be 9 over 12 into 100. Okay, so in any general reaction, percentage yield is always less than equal to 100. Okay, so suppose we have 10 grams of CaCO3, okay, is decomposed and only 4.8 grams of CaO is formed. Okay, so we have to calculate percentage yield. We have to calculate percentage yield of the reaction. So let me write down the reaction. CaCO3 is heated to get CaO plus CO2. So 10 grams was heated, so number of moles would be 0.1 because molar mass of CaCO3 is 100 grams, hence 0.1 and 0.1 moles of CO and CO2 is expected to be formed. But so let's say what should be the weight of CO2 that should be formed. 0.1 into molar mass of CO2 would be 44, hence 4.4 grams of CO2 was ideally hoped to be formed, or rather hoped to be formed. And how much weight of CaO was hoped to be formed? 0.1 into what is the weight of CaO? It is 56 grams, hence 5.6 gram is supposed to be formed. But the actual mass of, I can write here that actual mass of CaO formed was only 4.8 grams, hence percentage yield of the reaction would be 4.8 over 5.6 into 100. Okay, so you can just calculate this. Okay, so let's move on to next question. So if we have 20 gram impure sample, of, let's say, CaCO3, and which contains 10% impurity. Okay, so if percentage yield of the reaction is 75, then calculate the mass of CO2 present. If percentage yield of the reaction is 75, then we have to calculate mass of CO2 formed. Okay, so we have CaCO3, which will on heating decompose into CaO plus CO2, and we have 20 gram of impure sample which contains 10% impurity. Hence the overall mass which would be used for CaCO3 would be 18 grams. Okay, so 18 grams would actually be 0.18 moles. Okay, and percentage yield of the reaction is 75%, hence moles formed of CO2 after the reaction would be, this is mass and this is moles. Moles formed of CO2 would be 0.18 into 0.75. okay, this would be the moles of CO2 which would be formed, hence weight of CO2 or mass of CO2 rather, which would be formed after the reaction would be number of moles would be these are the number of moles into 44 grams. So you can just calculate it to get the final answer. Okay, so this would be answer should be 5.94 grams. Okay, let's see another example. So here we have a question that what mass of P4O10 was obtained. Mass of P4O10 was obtained when 1.24 grams of P4 reacts with 1.92 grams of O2. Okay, so if in the above problem only 2.272 gram of P4O10 is obtained, then calculate percentage yield. So first, this is the first part of the question, and the second part of the question is if only 2.272 grams of P4O10 is obtained, then you have to calculate percentage yield. Okay, so let's dive into the first part. So let me write down the reaction first. P4 plus O2 gives P4O10. Let's balance it by having 5 moles of oxygen here. Okay, now we are giving that mass is 1.24 grams of P4 is consumed and 1.92 grams of O2 is consumed. Okay, so what would be the moles? So moles would be obviously 1.24 divided by 124, which is the molar mass of P4. Hence moles used in the reaction for P4 would be 0.01, and moles of O2 consumed in the reaction would be we will have 1.92 divided by 32. Okay, so we will have that would be 0.06. Okay, so for finding the limiting reagent, we have to divide. First for P4 we will be getting 0.01 divided by 1, and for O2 we will be having 0.06 divided by 5. So obviously this is greater, hence P4 is the limiting reagent or limiting agent. Okay, so according to P4, number of moles of P4O10 would be produced would be 0.01. Okay, so what is the mass of or weight of P4O10 that would be produced? That would be simply, let's calculate the weight of P4O10. It would be 124 plus 160, it would be 284. Okay, so 0.01 into 284, which is the molar mass of P4O10, it would be 2.84 grams. So that answers the first part of the question. Now the second part is, what is the percentage yield? Percentage yield would be how much total weight was produced, which was 2.272, and how much should be ideally be produced at stoichiometric, or at stoichiometry it would be 2.84. Hence it would give out percentage yield to be 80%. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more questions on the same. Till then, good luck and goodbye.